All right, well, welcome back, folks. Let's go ahead and pick up with where we left off yesterday, and that was discussing atmospheric pressure. We talked about atmospheric pressures being the pressure exerted by the gases on Earth here, and we feel this atmospheric pressure because, again, we are immersed in this gas. And the way I want you to kind of think about this is that if you think of the Earth as one big balloon, and we are sitting inside that balloon, we can feel the changes in the amounts of gases that are in this balloon. So remember, we talked about how the pressure that a gas exerts is directly related to the number of particles that are in there, the masses of those gas particles, and that as they move around, they collide with everything. So if we're sitting in this one big balloon, you can imagine that if someone puts more gas inside this big balloon, we're going to feel that pressure change because there's going to be more gas particles that are inside that balloon. And so so that's how you want to think about it. So depending on where you are on Earth, the number of gas particles change. And because of the number of gas particles change, the balloon here then gets either bigger or smaller. We're going to feel more or less pressure. I also wanted you to think about it in terms of being in the ocean, for example, or being in water. So as we move up in elevation, the pressure changes. It goes down, it drops. Why? Because there's less particles up there. There's less particles up there as we move up higher and higher. In the same way then, as we move up towards the surface of the water, if we were swimming in the ocean, as we move up towards the surface of the water, we're going to feel less and less pressure because there are less water particles that are around us as we move up. Okay. And so if you kind of think of atmospheric pressure in that same way, then you can kind of understand how the pressure changes, the atmospheric pressure changes with the altitude that we're in. Okay. And so like I told you, as we were talking about yesterday, when we left off with this, we can measure those pressure changes. We can measure those pressure changes using a very simple device here. And obviously nowadays, the devices we use are much more sophisticated to measure atmospheric pressure. And also we use digital devices to do so. But this device here is a very simple way that we can use, a very simple tool that we can use to measure atmospheric pressure. And it takes advantage of the density of mercury. Okay? And so here we have what's called a mercury barometer. Okay? And so with this particular mercury barometer, what we have then is that we have mercury, and we talked about this, mercury filling in this bowl here, atmosphere, the gas particles around this dish of mercury, and we have a tube here of mercury, and a column of mercury that sits inside of this. Okay? And so the column of mercury inside this tube here, which we have marked off in units of millimeters of mercury, millimeters here. Here in the U.S., we use obviously empirical system, and if you check the weather channels, they will give you still the atmospheric pressure, obviously not in millimeters of mercury, not here in the U.S., but in inches of mercury. And I think today, I checked this morning, the pressure was about 29 inches of mercury. You'll see that given to on the weather services in the news. I think what the weather people, what are the weather people? Meteorologists. I'm sorry. What the meteorologists use is they use a different unit. They use what's called a bar, the bar unit, and they use the millibar. I think. Yeah, so they use millibar. So there's other units of pressure that we'll talk about in just a moment. But anyway, so we've divided up this test tube here in units of millimeters. And so the unit of millimeters, as the column of mercury moves up or down, we can measure how high this column is and use that to determine then the atmospheric pressure. Okay? And so the atmospheric pressure then can be measured in units of millimeters of mercury, and this unit here comes directly from the use of a mercury barometer. Okay? And so that's the origins of this unit of millimeters of mercury. But like I told you, here in the US, then we also use the unit of the weather channels, the weather services. I think will give it to you in inches of mercury. Inches, obviously, you can imagine in this column being measured off in inches instead of millimeters, and that's the origins of this unit of inches of mercury here. Okay. Like I said, there are other units that are used as well. If you look at the Weather Channel, the meteorologist uses there, I think, millibar. Sorry, so they use a unit known as millibar. Okay, put that in here. So they use a unit of millibar. The unit of millibar here. Okay. In science, we use a unit of pressure known as the atmosphere. And there's two that we use. We use atmosphere, and we also use I'm sorry, I got a kilopascals. Okay, right. So there are different ways that we can describe atmospheric pressure. So think back into chapter 3 when we talked about this. That when we measure any phenomenon, we measure any physical problem, we measure anything, there has to be a number and a unit as well. So these represent some units of pressure that we use. There are many other units of pressure that we use. And so whenever you see any of these units here, you're going to realize that particular measurement is a measurement of pressure. And so here, not just atmospheric pressure, but pressure as well. So these are some examples of some units of pressure that we have that we use here in science. Okay, that you'll see. Okay, all right. So when you take this barometer and you set it at sea level, then okay, the pressure that the column here is going to rise to about 760 millimeters of mercury. Okay, so it's 760 millimeters of mercury. That represents the pressure, atmospheric pressure at sea level. And like we pointed out, if you go up to the top of Mount Everest, okay, and you take the same barometer here and you measure it, the pressure is going to be less. The pressure is going to be roughly about 300 millimeters of mercury. And so the column then won't rise up as high as sea level. And so there it is. That is how we go about measuring then the atmospheric pressure. Okay. Okay. So with that said, let's go ahead and let's take a look at these units. Okay. So the SI units for pressure, okay, the unit for pressure that we use in the international system then is the Pascal. And so therefore the kilopascal, like I pointed out to you on the previous slide, okay, so if the Pascal is the unit of pressure, hopefully you can recognize this and do this, the kilopascal then, which is what I gave you, is going to be equal to 1,000th, 1 Pascal. It's going to be equal to 1,000th of a kilopascal. Or if you want to think about it the other way, 1,000 pascals is going to be equal to 1 kilopascal. Okay, so the prefix kilo here is just representing 1,000. Okay, so that's the SI unit for pressure. Okay, so whenever you see the prefix Pascal, which is named after the French chemist. So whenever you see the unit Pascal or the unit kilopascal, and kilopascal is used more often than the Pascal, okay, you will recognize that it's a unit of pressure. Okay, all right. So with that said, we just talked about millimeters of mercury, and I talked about atmosphere as well. And so if these are other units of pressure, we should be able to convert very much the same way here that we can do this conversion here. Okay? We should be able to convert between these units of pressure and the units of kilopascals and pascals as well. So let's go ahead and let's take a look at how that works. Okay? So we can take advantage of this relationship here. Okay? The relationship here allows us to do the conversion where 1 atmosphere is defined as being exactly equal to 760 millimeters of mercury, which is exactly equal to 101.3 kilopascals. And so let's just quickly remember what we do here. So you're going to take advantage of this relationship here. All 3 of these measured values are defined then as being exactly equal to each other. Okay, so therefore we're going to convert between, let's say if our conversion asks us to convert between atmosphere and kilopascals. So example, this is what we're starting out with. We're starting out with this unit of atmosphere. We're going to convert to kilopascal. We're going to take advantage of this unit here, okay? This relationship here, atmosphere to kilopascals. So if we start out with atmospheres, then the conversion factor will have atmospheres on the bottom and 101.3 kilopascals on the top. Okay, so that's how we would go about doing this. Okay, so let's say then let's do another example here. If we wanted to convert between millimeters of mercury, so we start out with units of millimeters of mercury, and we want to convert that to atmospheres, for example. Okay? Then we would take advantage of this and this relationship. Okay, so we would plug in as our conversion factor then 760 millimeters of mercury on the bottom and 1 atmosphere on top. So basic conversions that we will do, taking advantage of these three relationships here. Okay, the relationship between these three units here. Okay, let's go ahead then and let's take a look at some examples here that I want you to work out. Okay. So basically what we're going to do is we're going to be using basic conversions here. We're going to be doing conversions involving these three relationships. Okay, so let's take a look at an example. Okay. We have then, if we take a measurement, we were told that we have a pressure of 450 kilopascals. Okay, so we have a unit 450 kilopascals. Okay, and so this is what we were given to start out with. Okay? And we were asked to convert that and express that in units of atmospheres and in units of millimeters of mercury. So that's the conversion. Those are the conversions we want to do. Let's go ahead and we'll quickly do the conversion here. Okay, so what are we starting out with? We're starting out with 450 kilopascals. Okay, and we want to convert that into let's do the first one, into units of atmospheres. So the conversion here is from kilopascals to atmospheres. Okay, and from the previous slides, just make sure you have that in front of you. We're going to take advantage of the conversion factor we're going to use here then is going to be the relationship between atmospheres and kilopascals, which is 101.3 kilopascals. If we take that directly from the previous slide. Okay, so let's plug that in then with the units in the right place. So our conversion factor is going to be 1 atmosphere over 101.3 kilopascals. Okay, you plug that into your calculator, and then you'll get your answer. Then it's 4.4 atmosphere. Okay, so to 2 sig figs, make sure you keep that in mind. Significant figures here will count because these are all measured values. And so that's the pressure. Pressure 450 kilopascals in units of atmospheres. Okay, let's go ahead and do the second conversion. In the second conversion, then we are still converting between 450 kilopascals. So we want to change that to millimeters of mercury. Okay, and so what relationship will we take advantage of here? Well, we know then that 101.3 kilopascals is going to be equal to 760 millimeters of mercury. Again, this is taken directly from what we saw in the previous slide. So that's the relationship we're going to take advantage of. So let's plug it into our calculation here with our conversion factors. So 101.3 kilopascals will be in the denominator. Why? Because we want to cancel out units of kilopascals. Okay? And then we'll have 760 on top, millimeters of mercury on top. Okay, and so plugging that in, then you'll get your answer then as being 340 millimeters of mercury. Okay. Okay, let's go ahead. I'm sorry. That's the three. Let me check that answer real quickly. I think I might have did that wrong. So it's 450. So hold on one second. So 450 divided by 101.3 times 760. So that's 3,400. Sorry, let me go ahead and erase that. That obviously that didn't look right to me. Okay, so we have then 3,400 millimeters of mercury. So I'm sorry about that. Okay. All right. So that's that's how we do these conversions. Okay. That's how we go about doing these conversions. Okay. So please make sure you you write this down. Okay. And so what I'd like you to do then is let's take a look. So this is basically the only calculation that you'll have to do in this chapter. Okay. So make sure you're able to do these conversions. And so let's take a look at number 9 here in your problem set. So take a look at number 9 in your problem set, and I want you to work this one out really quickly. Take about a couple minutes, work out this problem, show your work, and then when you come back, I'll work this problem out for you. Okay, so take about a couple minutes, work out this problem. Okay, let's go ahead and let's take a look at what we have then. Okay, so we have then, we're going to start out with we're given 190 millimeters of mercury, so that's what we're given to start out with here. Okay, we want to convert that to kilopascals and to atmospheres. Okay, so let's go ahead. Let's work this out together. Okay. So again, these are just basic conversions that you, I think, considering what you just finished in chapter 12 with stoichiometry, this should be a very straightforward, simple conversion for you. Okay, so we're going to start out then with 190 millimeters of mercury. So this time we're starting out with this pressure. Okay, and let's go ahead and do the first one, and we're going to convert this to kilopascals. Let's do the first conversion. Okay. Okay, so what are we going to take advantage of here? The conversion factor here is going to be, the conversion factor is going to take advantage of the relationship between this amount, this pressure, and this pressure here. Okay, so we're going to use these two here to do this calculation. Okay, so let's go ahead and plug that in. Okay, when you work out this problem here, folks, for tonight's homework, you don't have to write this down. I'm just writing it out for you to point out that we're only taking advantage of these two here. What I gave you was the relationship between all three of them, which is 1 atmosphere, 101.3 kilopascals, 760 millimeters of mercury. For each of these conversions, you're going to choose 2 of the 3. You're not going to use all 3 of them. We're just saying that all 3 of them are equal to each other. But for each of these conversions here that you're going to do, you're just going to pick 2 of the 3. And these are the 2 that we'll pick for this conversion here. Okay, let's go ahead and plug it in to our conversion into our problem to work this out. Okay, so since we start out with millimeters of mercury, we'll have 760 millimeters of mercury in the denominator and 101.3 kilopascals in our numerator. So plugging that in, then you end up with 25 kilopascals as your answer. Okay, all right, let's do the second conversion then. Okay, again, we're going to start out with 190 millimeters of mercury. We're going to convert this time into units of atmospheres. Okay? And so we're going to take advantage of the relationship between this pressure here, which is 760 millimeters of mercury, and this pressure here, which is 1 atmosphere. So again, we're choosing this and this one. Okay, so we choose 2 of the 3, not using all 3 of those. Okay, so let's go ahead and plug that in to our calculation here, which will require that we put 760 millimeters of mercury in the denominator again to cancel out this unit here, and 1 atmosphere on the top. So writing that in, then we end up with a pressure of 0.25 atmosphere. So hopefully you got that as well. If not, please make sure you write this down to have it there for you to study. Okay. All right. Very good. Let's go ahead then. And let's do another one. Let me ask you to do one more. Let's do number 11 here in your problem set. So again, take a couple minutes to work out this problem here, okay, and then I'll work it out for you. Okay, go ahead and work on this problem. Okay, let's go ahead then and let's take a look at what we have here. Let's take a look at what we have here. This time we are given this pressure here, and we want to find the equivalent units in millimeters of mercury and in atmosphere, equivalent measurement in millimeters mercury and atmosphere. Okay, so let's go ahead and do the first conversion. So we start out with 775 kilopascals. Okay, let's convert that into atmospheres first, millimeters of mercury first. Okay, so we want to convert to millimeters of mercury. So like I said, I'm not going to write this down anymore. Let's go ahead, for the sake of time, I'm going to plug in the conversion factor here. So 760, so kilopascals, and it's going to be 101.3 on the bottom, 101.3 kilopascals on the bottom, and 760 millimeters of mercury in the numerator. Again, hopefully you can see that and got why we have to do that. All right, so with our answer here, then we end up with 562 millimeters of mercury. Okay. All right, let's go ahead and do the second one. Okay, so again, we're going to start out with 75 kilopascals. This time we're going to convert into units of atmospheres. Plugging this in, then it's going to be 101.3 kilopascals in the denominator, 1 atmosphere in the numerator. So if we plug that in, we end up with our answer then as being, let's do 7.40 times 10 to the minus 1 atmospheres. Okay. All right. So hopefully work out these, well, practice this. Your homework for tonight is going to be set A from chapter 13. Work on this here. I think it's a very simple calculation. I don't think it's going to be very difficult for you. But make sure you work that out. And then what we'll do tomorrow, and I'm running a little low on time here, because what we'll do tomorrow is, and we're going to go over the second case. And I'd like you to take a look at this prior to our meeting tomorrow. So we talked about how mass, the amount of the gas, affects gas pressure. So remember we talked about this, as you increase the amount of gas particles and effectively increase its mass, you're going to increase the pressure. Okay? And if you decrease the amount of the gas, you decrease the mass of the gas, you decrease the pressure, to the point where if you have no gases in a vacuum, for example, the mass is 0, the pressure is going to be 0. And so we said then that there is a second factor that also affects gas pressure, and that is the movement of the gas particles. And so this is where I want to pick up with tomorrow in our discussion, and that is how does the movement of the gas particles relate to gas pressure, and how do we track movement? How do we track the motion of a gas? We were able to, in the previous discussion, we were able to track measure pressure and talk about that. How do we determine then the motion of a gas? What is that related to? Okay. All right. So take get the homework done. Take a look at that, and then we'll continue with this discussion tomorrow. Okay. All right, folks. Again, any questions on the material today? Stop by after school today, 1:30 to 2:30, and ask your questions, and then be ready for tomorrow. Okay. All right, folks. If not, then I will see you tomorrow.